In this video, I'll be skipping ahead to problem number 4, still dealing here with 6.5 exercise 1. 6.5 exercise 1, problem number 4. So to set up the problem, I've gone ahead and written it out horizontally, separating out the single premise from the conclusion, of course, with a double slash. So the second part of my setup, again, is to assume that this argument is in fact invalid. To assume that it's invalid, I define the premises, in this case, they're just a single premise. I define the premise as being true by running a t directly underneath the main logical operator, which of course is the tilde. Once I've assumed the premise to be true, and continuing with the assumption that it's invalid, I must define the conclusion as being false. So I'll write an f directly underneath the main operator of the conclusion. The next step is to ask myself, given this assumption that the premise is true and the conclusion false, given this assumption, what else can I know? I can know two things immediately. If the value of the tilde is true, working backwards, I can know that the value of the triple bar is false. And likewise, now examining the conclusion, if the value of the tilde is false, I can know that the value of the horseshoe is true. And notice that in both of these cases, I didn't figure out any information about one of the two variables present here, either the I or the j. All I was able to initially discover was the value of the two operators on the inside of the parentheses. I was able to figure out the value of the triple bar and the value of the horseshoe. Even though I didn't figure out the value of one of our variables, figuring out the value of an operator was in fact useful information. So given that I now know that the value of the triple bar is false, and the value of the horseshoe is true, same question applies. What else can I know? With this additional information at hand, what else can I know? So let's examine the horseshoe. We've got I, horseshoe, j. We don't know the values of either of them just yet, so question mark, horseshoe, question mark is true. Can we know anything here about the values of I and j respectively? Well, again, consult your truth table, and we know that there are three different ways for a horseshoe statement to be true. So all we really know is that I can't be true while j is false. That would give us t horseshoe f, which of course is false, and that goes against our assumption. So no immediate information can be gained by examining just the inside of the parentheses on the conclusion. So now let's turn our attention to the triple bar. The triple bar we figured out has a value of f. So given that information, can we know anything about I and j? Well, again, consult your truth table, and you'll see that there are two ways for a triple bar to be false. It could be t triple bar f, or the other way around. It could be f triple bar t. So again, no immediate information is gained, with one obvious exception. The one thing that we can know is that I and j don't have the same truth value. If they had the same truth value, if for instance they were both true, or for instance both false, then that would give us a t under the triple bar. So what we can know, just a teeny small bit of information, what we can know is that I and j don't have the same truth value. That is, one of them's true and the other one's false. So with that information now in mind, continuing to think our way through the problem step by step, given again that they have different truth values, let's return to the inside of the parentheses on the conclusion. Given that either I is true and the other is false, or vice versa, which one is it going to be? Could we again have t horseshoe f? Well, that would yield a value of false under the horseshoe. So given that there are two different truth values, it must be the case that I is false and j is true. So we can go ahead and pencil that in under the values of I and j here in the premise of the argument. I is false and j is true. So now we figured out the value of all the variables as well as all of the operators. And unlike in our first problem, in problem number 1 in this section, we've not arrived at any contradiction. The values do fit, there aren't any inconsistencies. So what does that mean? Well, that means that it is possible for our assumption to be the case. Our assumption was that the argument was invalid, and that didn't again lead to any contradiction, so it is possible. Therefore, we finish up the problem by writing down invalid, and that's all there is to it.